Yes, next property, texture. This is one of the main important things. Let me give you an example. Let me give you the best example. And we are learning so much. We are learning so much, and we are having all the organs of eyes, ears, all the sense organs are working. The people who are blind, they can't see, and they can't go with what we can say luscious property. They can't go with what is the first one? Appearance. They can't go with. Definitely, what they'll go? Texture, by the feel of, by the sense of touch. By the sense of touch. Am I right, children? Yes or no? So they'll be having much more idea than what we are having. But simply, one more example I have given. By seeing the wallpapers, it's a fake wall. I mean, what I meant to say, it's a fake wood texture. But simply by seeing it, what we decide that it's a wood. Yes or no, children? But by the sense of touch, sometimes these sensory organs plays a major role. When we go with the texture, what we'll feel? We can easily identify the thing. But we can't give the exact color of it. But we can say that what object, what it belongs to. It belongs to plastic, or it belongs to steel, or it belongs to like any other fiber, like wood, silk, hardness also they can say, by the texture, simply by the sense of touch. Okay, we can integrate the appearance with the texture. So when we go with the wallpaper just shows the thing, and we feel that it's a original one. But once we touch the wall and when we feel it, we definitely by appearance both like like what we can see directly proportional to each other. When we touch, definitely we'll say that this is not the texture, it's just a wallpaper. Okay, so almost all these are made up of plastics. Then we go with the metals. When we touch the metals without saying, or when we are doing a very good, like what we were concentratedly when we are going with the work continuously. Definitely when your mother serves you a cup of milk, without saying, when you touch the cup of milk, if it is hot, or without touching, you can feel that the material, whether it belongs to glass or steel or plastic. Am I right?
And even sometimes ceramic glasses of milk.
Yeah, dear?
Ma'am, sometimes they're also ceramic glasses.
Yeah, sometimes ceramic glass. But without seeing it, we can feel it. We can differentiate it. We can sort out it that to which material it belongs to. Yes or no? Yes. Or without seeing, we can feel the states, whether it is liquid, whether it is gas. How can we feel? When I'm holding it, I can't feel any gas. When the gas is blown with the pressure, definitely I'll feel it. Deflatten the balloon and remove the cap. When you leave the air with force, I can feel it. We can feel the wind. Yes or no? Yes or no, children? So it's nothing but texture. Any doubts? Any doubts? So by simple texture, we can easily identify, we can easily know that the material to which it belongs to, and we can easily categorize the substance. Yes or no? It's nothing but a simple texture. Next. State. Neha, you got disconnected suddenly. Sometimes this is the problem with me also, but I prayed like anything today. I shouldn't get any disconnections or anything else. That's why I'm going very slowly. Okay. Next, state. State means you can see that if I'm holding this, solid. When I'm drinking water, liquid. If I on the switch, fan, I feel like comfortable, gas. Okay, states of matter can be classified into three: solids, liquids, gases. On what concentrations they are classified? On what sorting of criteria they classified into three? First one, arrangement of the molecules. Here, this picture shows the almost the entire concept you can go with. Okay, here we can see that how the particles are arranged. Here the particles are compactly arranged. The particles inside the solid, they're compactly arranged without any gap. That means that's where solids are very strong. The solids are very strong. Why? Because the particles are arranged in such a way that there is no gap between it, so that they are very strong. This is strong. If I throw it, it won't break. But anyways, that is different. If I throw the gas, definitely it breaks because of the property of the material. Understood? But it can hold the water or liquid. That means it is made of solid. Understood? So here we can see in the liquids, the states of matter, the liquid state, we can see that the force of attraction between the molecules, the force of attraction between the particles in the liquid, a bit far from each other. That means less force of attraction when we compare with solids. That's why solids are rigid. They are very tightly packed. Until we give the force, they won't move. The suggestion is there, until I forcefully throw it, then only it moves. But liquids comes under fluidity. Fluidity means because of the less force of attraction, they can easily flow. They can easily move. Understood? If we go to the example like gases, when we compare with solids and liquids, gases are having weak force of attraction. Weak force of attraction in the sense few amount of gas. Few pressured gas also, it spreads that entire room. That means they don't want to be in contact. The particles are just spread out. So gaseous particles are highly fluidity than liquids. Understood or not? That's why when we go with the laboratory technique with some chemical properties, with some chemical reactions, we go to chemical reactions, the setup is completely enclosed. So that energy won't be released out, energy won't be entered into during the reaction. Because gaseous particles are having high kinetic energy. Kinetic energy means the energy obtained by a moving object. Potential energy means when the object is at a stationary place, standard without moving, that is the energy. But when we go with the states of matter, all these particles, solids are having weak kinetic energy because they won't move. They'll be like that with the force of attraction. If one particle is there, the same particles will be bonded with the other particle. So though this particle wants to move also, the other particle won't allow. Understood? If two friends are there, one is very quiet, very dignified. He or she knows the boundaries. They are well matured. They know that what is good and what is bad. The other one is like tomboy. Okay, the other one is like tomboy. But these both are very good friends. So if the other one wants, he can't identify or she can't identify whether what she's doing is whether good or bad. Definitely, the other friend. Definitely, the other friend, what the other friend will do? he or she tightly packed the front and he won't allow to go out of the track. That means the force of attraction between them are very strong. They are very well bonded. They are very well bonded. And children, at the same way, here solids, each particle is having a certain force of attraction. They are very tightly packed. They won't allow it. So that's why no kinetic energy. No kinetic energy in solids. In case of liquids, Neha, are you getting it now? Whatever I'm saying. Monica?
I understood that solids are packed tightly, liquids are tightened a little bit like
loosely,
and gases are a lot of free.
Yes, ma'am. So the gases are like, ma'am, they are like very far apart from each other.
Yes. Yes. Yeah. Okay, liquids. That's why the property of solids are rigid. They'll undergo rigidity. Liquids and gases comes under fluidity. Because they flow, it doesn't require any external energy to move it from one place to the other. They just flow it. Why? Because they are having molecules are having kinetic energy. When they're moving, they strike to each other and they move. The best example I can give, when I lit an incense stick at one corner, how the aroma, how the smell passes from one corner to the other. How it passes? Why? Because the particles from the incense stick, listen carefully, the particles from the incense stick come in contact with atmospheric gases. They're having kinetic, they'll strike with each other. By striking with each other, they move from one corner of the room to the other. Understood? The same example for gases can be applicable for when your mother is cooking something, when your mother is giving heat while cooking, so that the particles will be having higher kinetic energy, so that whatever your mother is cooking, so that near the gate itself you come to know that your mother is cooking particular dish. Because of the gaseous particles of the that dish will come and collide with the strike with the gases present in the atmosphere. By striking with each other, they'll move from one corner to the other corner. Any doubts? Any doubts? Neha, Monica, Anjali, Pragya, Anjali.